Let's take a look at what an inverse function is. This is a concept that's really simple, but the execution can get really difficult. An inverse function is, and it's notated by f of x to the negative 1 power, or it can say find the inverse of the function. But what you do is you switch the x and the y in your equation, and then you solve that equation for y. Let's look at f of x is equal to, let's say 3x minus 5. The first thing we have to do is switch the x and the y. Well, you don't see an x and a y, but if you'll remember, you can always replace your f of x with y. So now we have y is equal to 3x minus 5. So let's switch the y and the x. That's going to give us x is equal to 3y minus 5. Okay, that part's simple. Now we're going to solve it for y, just like you've been doing since you learned how to find y is equal to mx plus b. We're going to add 5 to each side. So now we have x plus 5 is equal to 3y. Then we're going to divide both sides by 3. So now I have x plus 5 over 3 is equal to y. Now you do want to reflex this over the equal sign and put it into standard form so that you have y is equal to x plus 5 over 3. Okay. This is your inverse function, and you could write it f of x to the negative 1 is equal to x plus 5 over 3. Okay, so let's look at one that's a little bit harder. Okay, let's look at one that's a little more difficult. F of x is equal to 7 to the x over 5 power. So first let's make f of x a y. We've got y is equal to 7 to the x fifths power. And then we're going to switch the y and the x. So now we have x is equal to 7y over 5 power. Alright, now solving the equation. You see the actual conversion to the inverse was just the same. It wasn't any problem. But here's a whole new layer to it. Do you know how to solve an equation that has a fractional exponent? Well, this particular one gets into logarithms. But this is where the whole concept of inverse functions gets pretty difficult. It can be any kind of equation once you switch that x and y, and then you have to deal with how to solve it, how to manipulate it. This particular one, using fractional exponents, is going to deal with logarithms. So what we're going to do here is we're going to say, all right, the 7 is your base because it has the exponent. So to convert it, we're going to do log base 7 of x is equal to y over 5. That's just a simple property of logarithms. And if you want to know more about logarithm properties and how to deal with them in equations, I'll drop a link to that playlist below and you can check that out. Now, once you have it in this format, remember, your goal is to get the y all by itself. Well, what's been attached to the y now is the 5. So all you're going to do is multiply both sides by 5. So now we have 5 log base 7 of x is equal to y. And then once again, you're going to want to reflect that so that it says y is equal to 5 log base 7 of x. And that's how you find the inverse function of something with a fractional exponent.